Hello! Welcome to Algebra Prep Academy. In calculus, an integral represents the area under a curve. However, on your exams, you may be asked to create an approximation of the integral rather than actually solving the integral. In order to do this, you must use one of the three Riemann sums. The sums are the left Riemann sum, or LRAM, the right Riemann sum, or RRAM, and the middle Riemann sum, or MRAM. Given a set of data, we can use these sums to estimate the area under a curve. Let's look at some examples.
Let's say we are asked to find LRAM for a set of data points representing the equation y equals 1/2 x squared. The data points would be 0, 0, 2, 2, 4, 8, 832, 1272, and 1498. This can be represented graphically as shown here. Finding the LRAM consists of adding the areas of a series of rectangles together made from multiplying the step size of an interval with the height of the rectangle, such that the curve of the line intersects at the top left point of each rectangle. This gives us the area of an individual rectangle. Repeat the process for all the rectangles to find LRAM. This can be represented as x1 minus x0 times y0 plus x2 minus x1 times y1 plus x3 minus x2 times y2 plus x4 minus x3 times y3 plus x5 minus x4 times y4. The difference in x values is the step size and the y values is the height. For this problem, it would be 2 minus 0 times 0 plus 4 minus 2 times 2 plus 8 minus 4 times 8 plus 12 minus 8 times 32 plus 14 minus 12 times 72 equaling 308. LRAM is an under-approximation of the curve because the integral of 0 to 14 half x squared dx is equal to 457.3 and 308 is less than 457.3.
Now for example 2, let's say you're asked to find the RRAM for the same set of points in equation. This time, to find the area of each rectangle, you would multiply the step size of an interval with the height of each rectangle such that the curve of the line intersects at the top right point of each rectangle. Repeat this process for each step and add the areas of each rectangle together to find RRAM. Drawing out the rectangles help. For our problem, this can be represented as RRAM equals parenthesis x1 minus x0 and parenthesis times y1 plus parenthesis x2 minus x1 parenthesis times y2 plus parenthesis x3 minus x2 parenthesis times y3 plus parenthesis x4 minus x3 parenthesis times y4 plus parenthesis x5 minus x4 parenthesis times y5. Plugging in the values, the RRAM equals 2 minus 0 times 2 plus 4 minus 2 times 8 plus 8 minus 4 times 32 plus 12 minus 8 times 72 plus 14 minus 12 times 98, which gives us 632. For reference purposes, the RRAM is an over-approximation of the curve because the integral from 0 to 14 of 1/2 x squared dx equals 457.3 and 632 is greater than 457.3.
For our third example, we'll take a look at MRAM. Finding the MRAM for the same equation works a little differently. You are still adding the areas for a series of rectangles, but this time you must plug in values of x into the function to find the height of each rectangle. This is because in MRAM, each rectangle intersects the function at the average of the x values. For example, to find the area of the rectangle between 0 and 2, you would do 2 minus 0 times f of 1. You must plug 1 into the function because the average of 0 and 2 is 0 plus 2 over 2, which is 1. Do this for each of the points already given. The new set of points is 1, 1/2, 3, 9 halves, 6, 18, 10, 50, and 13, 169 halves. Using the original x values for the base and the new y values for the height, you can find the area of each rectangle. After adding each of the areas, we get a total area of 451, which is slightly less than the actual area of 457.3. This particular MRAM is an under approximation, but it is helpful to remember that MRAM typically yields a more accurate estimate than either LRAM or RRAM.
Hey, we're your tutors, Marco, Prince, Ollie, and Sam. If you enjoyed our video, feel free to hit the like button below, or subscribe to our channel. Once again, thanks for watching LRAM Prep Academy.